This is our video for Unit 8, Day 6. So we just got back from the break. We had our review, and we took the quiz on Pythagorean theorem. What we're going to do now is look at some other types of things involved with right triangles. So really focusing on now is called right triangle trigonometry, right triangle trig. So the building blocks for this trig is the three basic trig ratios, which are sine, cosine, and tangent. We're going to go through each one of those today. So anytime we have a right triangle, we can, if we pick one of the two acute angles in the triangle, so here let's say we take B, we can label all the sides in reference to angle B as either opposite, adjacent, or hypotenuse. So we know the hypotenuse, where I talked about, is the longest side for right triangles across from or opposite the 90-degree angle. Right, opposite means across the triangle from. So this one here would be opposite. Side AC would be opposite angle B, and then the adjacent side would be right next to it. Adjacent means next to. So we can label all three sides in reference to an angle in the triangle, and this is how we form our trig ratio. So the ratio of the opposite side to the adjacent side that's called the tangent ratio. So that's what the tangent ratio is. For short, we just say that tangent equals opposite over adjacent. We can even abbreviate that, say tan equals OPP over ADJ, opposite over adjacent. And just breaking this definition down a little bit further, right? Remember that ratio is a word we talked about in Unit 1. Ratio is just another word for a fraction. Right, so we're creating a fraction. The opposite side goes on top, the adjacent side goes on the bottom. Tangent ratio is opposite over adjacent. So in our example on the picture, we're using B as a reference. It says tangent for angle B would be the length of AC, the opposite side, over the length of BC, the adjacent side. Alright, then below we'll do one example where we have the actual numbers written in there. So this first one is asking for tangent angle T. So here is angle T, so we're going to mark that so we know that's our reference. We'll label all three sides in reference to angle T. So the 4 would be across the triangle, that would be the opposite side. The 3 is right next to it, that would be the adjacent side. The 5, the longest side that's across from the right angle, is the hypotenuse. Right, so tangent is opposite over adjacent. So on this triangle, that's going to be 4 over 3. Right, then if we switch it up and start looking at a different angle, say we're looking at angle U now. Now it's going to change, because now the opposite side is going to be 3, the adjacent side will be 4. 5 will still be the hypotenuse though, because it's still the longest side of the triangle, still opposite the right angle. But now if I look at tangent for angle U, that's going to be opposite 3 over adjacent 4. So this example to the right here, I want you to try this one on your own. So you can pause the video and try this one on your own, and then go ahead and fill out your next section notes. So the next one of our trig ratios is called the sine ratio. S-I-N-E, sine ratio. This is the ratio of the opposite side to the hypotenuse. Right, again, this is a ratio. For short, we can say sine is opposite over hypotenuse. Right, we abbreviate sine by saying SIN. That's opposite over hypotenuse. So again, look at the example triangle is asking for sine angle B. So angle B is our reference. Right, if we look at angle B, AC would be the opposite side. BC would be the adjacent side, and AB would be the hypotenuse. Right, so this ratio AC to AB is the ratio of the opposite to the hypotenuse. Right, it's our sine ratio. So again, we'll do one example here together and leave the other one for you to do on your own. So for this first example, we're looking at sine for angle A. So here's angle A. We're going to label all three sides opposite, adjacent, hypotenuse. So here the 15 is the opposite side, the 8 is the adjacent side, and the 17 is the hypotenuse. So sine is opposite over hypotenuse. So here that's going to be 15 over 17. Again, if we switch up and want to find sine for angle B, right now we have to relabel the sides. Now 8 is the opposite side, 17 is still the hypotenuse, and 15 is now the adjacent side. So sine for angle B will be 8 over 17. Now the triangle on the right, this is an example for you to try on your own. Alright, we'll go over these before we start going over the practice problems at the end of the notes. So the last of our basic trig ratios is called the cosine ratio. So cosine is a ratio of the adjacent side to the hypotenuse. Again, for short, we just say cosine is adjacent over hypotenuse. So our example, again, we're looking at angle B. So we label our sides. AC is the opposite, BC is the adjacent, and AB is the hypotenuse. The cosine for angle B would be BC, the adjacent side, over AB, the hypotenuse. So we'll do this example on the left all together and then leave the one on the right for you to try on your own. So first I'm looking at cosine y. Right, so I look at angle y and I label all the sides in reference to angle y. So looking at angle y, 8 would be the opposite side, 6 would be the adjacent side, and 10 would be the hypotenuse. So cosine is going to be adjacent over hypotenuse, which will be 6 over 10. Then if I want to switch up and look at cosine x for the second problem, I relabel the sides. I have to switch adjacent and opposite. Hypotenuse stays the same. That's always going to be the longest side, but now the adjacent side is this 8, and the opposite side is that 6. So that makes my cosine now for x 8 over 10. this one on the right, try this one on your own. So one of the things you're going to have to do with these trig ratios is remember the definitions for each one, sine, cosine, and tangent. So there's a phrase that we use in math that you'll hear probably in all your math classes from here on out when you talk about trig. Um, it's called SOHCAHTOA. SOHCAHTOA. So this is a way of remembering the definitions for the three trig ratios. So SOH stands for sine equals opposite over hypotenuse. The CA stands for cosine. It's adjacent over hypotenuse. And TOA stands for tangent, is opposite over adjacent. So what we're going to do here on this triangle is we're going to find all three, sine, cosine, and tangent, for both angle D and angle E. So we'll go ahead and just write this out, set it up. We're going to find sine D, cosine D, and tan D. Then we're going to find sine E, cosine E, and tan E. So we'll start looking at angle D, and we'll label the sides accordingly. So 28 is the opposite side, 21 the adjacent, and 35 is the hypotenuse. So if I'm looking for sine, that's opposite over adjacent, so that's, sorry, opposite over hypotenuse, that's 28 over 35. Cosine is adjacent over hypotenuse, that's 21 over 35. And tangent is opposite over adjacent, that's 28 over 21. So once we label the sides, it's just putting them in the right part of the fraction. The next one, angle E, we have to relabel the sides. Looking at angle E, 21 is now the opposite side, 28 is now the adjacent, 35 is still the hypotenuse. So now our sine is 21 over 35, opposite over hypotenuse. And notice that that's the same as the cosine for D. Same thing, I look at E, the cosine for E would be 28 over 35, adjacent over hypotenuse. And that's the same as the sine for angle D. And the last thing I look at is tangent for angle E. It's going to be 21 over 28. Right, and that's the reciprocal, right, which means flip version of tangent for angle D. So this gives us two properties for sine and cosine of these special kind of angles. So if D and E are the two acute angles in a right triangle, that means together they have to add up to 90 degrees to make the whole thing 180, which means D and E are complementary angles. So for complementary angles, we have two properties for sine and cosine. First is sine E equals cosine D. They have the opposite sines and cosines, right, and vice versa. So the opposite sines and cosines for complementary angles. And the second thing we see is that the tangents are reciprocals of each other. Right? So reciprocal means when you flip something, that means 1 over that number. So tangent D equals 1 over tangent E. Right, that's a reciprocal or a flip. So that's two properties for sines and cosines of complementary angles. Something you'll see again in Math 2, but if you draw this picture, you can always see that just by finding all these trig ratios. So again, if you want to look for any other videos or resources to help you explain this, make sense of it, search for trig ratios or sine, cosine, and tangent.